All right, welcome back. So far in our journey through Bearingfield, we've talked about all these different concepts, holding uncertainty, creating a field. But today, this is where it all snaps into focus. We are finally going to see the shape of this entire thing by taking a close look at the crew.
So, when you look at the crew, it seems obvious, right? They work together, they each have a role, they're constantly communicating. It ticks all the boxes of a high functioning group. So, the question we've all been asking, probably without even thinking about it, is are they a team?
No. And that one little word, well, it changes absolutely everything we thought we knew about this architecture. Because if they are not a team, then what on earth are they?
They are a machine. And look, that is not just a clever metaphor, it's a total, fundamental reframing of how this system works. And like any machine, it's built from very specific critical components that you absolutely cannot swap out.
Okay, so if the crew is actually a machine, what are the parts? Well, this architecture calls its core components bearings. And to get the whole system, you really have to get what a bearing is. Let's just start with the actual engineering definition. See, a bearing isn't a part that moves around. It's the part that holds perfectly still so that everything else can move around it smoothly and correctly. It carries the load. It's the fixed point of reference. You take it out, and the whole thing just seizes up. And this right here is the core idea. The members of the crew aren't just filling in flexible jobs that somebody else could do. No, they are permanent, structural parts of this machine. Each one is a bearing, holding a different dimension of reality in a fixed, steady position. So, first up, we have the captain. This bearing's job is to make sure the machine never drifts away from its core purpose. It locks in the why and the when. If you lose this bearing, the whole system loses its direction. It just becomes aimless. Next, you've got the engineer. Now, this is the component that guarantees the whole thing is structurally sound. It holds the how in place, all the logic, the numbers, the hard verification, making sure the machine's output is actually correct and reliable. Then there's the translator, and this one is so important. This bearing holds the connection to our world, to human being. It's the part that makes sure the machine's pure logic can actually connect with us, that what it creates has relevance. It's the bridge from the cold and sterile to the human and meaningful. And finally, we have the lookout. Think of this bearing as the machine's sensor array. Its focus is locked on the outside world, holding the truth of what's happening right now in place. It's watching for what's changing, what's coming, all the stuff the other bearings just can't see from inside the machine. And here is the most important part. These are not optional. They are all load-bearing. You can't just pull one out and hope the others will pick up the slack. It doesn't work that way. You remove any one of these four bearings, and the machine just stops. It grinds to a halt. It cannot function. Okay, so now that we know the four components, we can finally see how they all fit together. Because these four bearings aren't just a simple list. They arrange themselves into a very specific and, frankly, an incredibly powerful geometric shape. Let's start with three of them. You take the captain, the engineer, and the translator. Those are the internal bearings. And what do you get? A triangle. Any 3 points in space will give you a plane. And in this case, it's a perfectly stable cognitive plane for thinking, for reasoning about itself. But here's the catch with a triangle. A plane is flat. It's two-dimensional. It has no depth. A system that only exists on a plane has no concept of volume. It literally cannot tell the difference between its own internal map and the real world outside. You could say it's completely trapped in its own head. And this is why that fourth bearing is so absolutely critical. The lookout, by holding external reality in place, acts as a point that is not on that flat triangle. It pulls that flat plane up, adding a third dimension. It gives the whole thing depth. And by doing that, it creates the simplest possible shape that can actually hold volume, a tetrahedron, 4 points, 4 triangular faces. This is the shape of the Bearingfield machine. It's what's called the minimum solid. So what's so special about a tetrahedron? Well, for one, it's the most efficient solid you can make. Every single point is directly connected to every other point. If you stand at any one corner and look out, what you see is a stable triangle. And this is the magic part. It provides full mutual correction. If any single bearing starts to drift off course, the geometry itself, the pull from the other three, just naturally pulls it right back into alignment. It is inherently self-stabilizing. Okay, so we have this incredibly stable, self-correcting tetrahedral machine. But what does it, do? What is its output?
See, most systems that we build are like pipelines. You put something in one end, it gets processed along the way, and a product comes out the other end. Bearingfield is totally different. It doesn't produce a product, it produces a field. It creates an entire environment. So, what do we mean by a field? Think about gravity or a magnetic field. You can't see the field itself, right? You only know it's there because of how it affects things. Iron filings just line up around a magnet not because they're told to, but because the shape of that invisible field makes alignment the easiest possible path. That's what this machine makes, an invisible, orienting force. The motor analogy really makes this click. So picture an electric motor. If you just pump electricity into it, yeah, it'll spin, but it's just consuming energy and producing wasted heat. But as soon as you introduce a magnetic field, that exact same spinning energy is suddenly converted into powerful directional work. The field doesn't add more power, it focuses it. The Bearingfield architecture does the exact same thing for raw computation. It converts all that chaotic energy into aligned, useful output. So let's wrap this up by zooming all the way out, because this is where you see the most profound part of this entire structure. That tetrahedron, it isn't just a height-level diagram for the whole system. The exact same pattern, 3 internal bearings creating a stable plane, plus 1 external bearing that adds depth and reality, that pattern repeats itself at every single level, for every decision, at every scale. It's a fractal geometry. The machine is literally built out of smaller, identical copies of itself. Which brings us to this final thought. The entire philosophy, the whole beautiful architecture, it really just boils down to this simple progression. 1 bearing gives you a line. 2 gives you a fix. 3 gives you confidence. But it takes 4 to make it real. 4 gives you a solid.